So hello everyone and I welcome you all to APJ Academy, where we are nurturing the young minds of India to become doctors and engineers. And in today's class I am going to teach you that how to solve numericals related to the Coulomb's law and the electrical field. And I'll be sharing my personal very important tricks so that you can solve your questions related to the Coulomb's law and electrical field within seconds. And it will be very entertaining sessions for you, and I'll be there in your journey from becoming a student to doctor. NEET preparation hashtag 2022 and 2023. So if you do not know about me, let me first introduce myself, but before that I want that you please mark the quality of the broadcast. Is everything fine? Is everything fine here? And you are able to see me? We are live now, right? So please let me know, please. Join now, join. So I hope that I am audible and visible, and I'll be starting. I hope that I am audible and visible, and now I am starting with the session. Wait. Okay. So my name is Manoj Kumar. I am physics educator on APJ Academy, and I'll be there in your journey from becoming a doctor from student. Previously, I was associated with very renowned institutes, online and offline both. I am having 8+ years of teaching experience, and I guided more than lakhs of students in this journey. And always, I tell my students about this one quote. What is this quote? The quote says that winners and losers have same goals. What is the goal, sir? The goal is to become a doctor. All the persons who are filling the form of NEET wants to become doctor, isn't it? Are they filling form to become a compounder? Tell me. Are they filling the form to become a nursing officer? No. All who are filling the form of NEET exam, all who are filling the NEET exam have their goal in their mind that they want to become a doctor. And the journey of becoming a doctor from student is a huge journey, is a huge spike. And in this journey, you require a mentor, right? Those mentors who will be guiding you that how you should be preparing for the NEET exam, because this is the most toughest exam, I would be saying, for the school students, right? So this is required. So for providing you a successful journey, for providing you the structured course, we have started this program. The program is free classes. Regularly we are providing on this YouTube channel. So I want that you please subscribe this YouTube channel and hit the like button, because if you miss my class updates, then it will affect your score, it will affect your chances of getting into the top colleges of India. Hello Jay, hello. So today what we are going to learn is about Coulomb's law. So let me start the topic. After that we will discuss some other things. So I am starting the topic with the Coulomb's law. Coulomb was basically an engineer. Coulomb was basically an engineer, a French military engineer, if I am more specific about that. And he told us, he gave us a very simple formula that if you keep two charges, that is Q1 and Q2, separated by a distance r, then these charges will be exerting force on each other, and the force magnitude is k times, k is a constant of Coulomb's constant, the product of the charges Q1 and Q2, and inversely proportional to the square of the distance between them. So force is equals to k Q1 Q2 by r square. This is the magnitude of the force given by the Coulomb's law. So this law has its limitations as well. There are some limitations. What are the limitations of Coulomb's law? First of all, these are applicable only at point charge. Only for point charge. Okay, so this is only applicable for the point charge. Second thing, this is only applicable for the charges which are at rest. Charges must be at rest. Why, sir? Why? Sir, what happened that if charges are moving? If charges are moving, then it will be considering as current, and if current is flowing, then magnetic field will be there, and if magnetic field will be there, and if one charge is moving, then magnetic force will be there. So it will be a combination of two forces, electrostatic forces as well as the magnetic forces. So we are not considering those forces in our consideration. So these are the two limitations. First, that this is applicable only for the point charges. Second, charges must be at rest, and third, the distance must be means I would be saying that it must be greater than the nuclear distance, which is 10 to the power of minus 15. So distance must be greater than 10 to the power of minus 15. So that is the two important point which we need to keep in our mind about the Coulomb's law. The value of K, the value of Coulomb's constant K is 9 into 10 to the power of 9. Unit is very important. Most of the time you will get that this unit, what is the unit of K in Coulomb's constant? What is the unit of K in Coulomb's constant? This question has been asked so many times in your exam. So what is the unit here? What is the unit? If I need to find out the unit at any time, there is very simple trick what you can apply. The trick is, you can keep this constant alone and put all other variables on one side. Then you will be getting a simple formula, and using that relation you can easily find out. So if I am keeping this as standalone quantity, as standalone variable on one side, and pulling all the other variables on the other side, then I'll be getting a simple relation. What is the simple relation here? So simple relation is K is equals to F R square upon K Q1 Q2. So this is a very simple formula which I am getting for K. So the unit will be, force unit is Newton, R square unit is meter square. So the unit is Newton meter square per Coulomb square. So unit is Newton meter square per Coulomb square. So this is the unit. These are the limitations which we are having. Okay. So I hope that all these things are important. I have some more points to be added in this. This K is also having some other values. I can write that this K is K is equals to 1 upon 4 pi epsilon naught. Epsilon naught here is, this is pronounced as epsilon naught, and actually this is permittivity. This is the pronunciation. And this is permittivity. Okay, so we have K is equals to 1 upon 4 pi epsilon naught. Epsilon naught is the permittivity. Okay, what do you mean by permittivity, sir? I couldn't able to understand that how this value is defined by the scientist. So I am telling you that when I am saying that k is equals to 1 upon 4 pi epsilon naught, what does it mean? That 4 pi represent that it is it is the force, or it is the constant which depends upon the 3D environment. It will be happening in all the other environments, all the other variables. That's why here is 4 pi. Okay, so 4 pi means it is going in all directions. This we will be deriving from Gauss law later on. And this epsilon naught permittivity, so permittivity means permission. This means permission, right? If permission force is proportional to permittivity, if permission is high, the required force will be less. Assume that you are two friends. You are two friends talking to each other. Randomly there will be casual talks, right? Usually the friends talks in a different manner as compared to the talk which they will be doing in front of the parents. So this is friend 1, this is friend 2. So they are talking with each other. Might be they were fighting with each other, or might be they are attracting towards each other. And think about a situation where one parent comes. So when parents comes between the two friends, then what would happen? There is some permission issues. There are some restrictions which type of talks they can do, right? So there would be some hindrance. So if permission is less, then force is increasing, that they need to follow some other path, right? They need to restrict those things which they will be that they were discussing earlier, isn't it? You were discussing something with your friend, like, "Aur beta kya kar raha tha?" Aise, like this. You will be using very slang language, right? But when you were in front of your parents, then you won't be using those sentences, isn't it? So you might have seen these things in front of you in real life. So physics is nothing but just an observation we have. So k value is 1.4 pi epsilon naught, and epsilon naught is the permittivity, which means the permission, and f is proportional to 1 upon epsilon naught. Epsilon naught is a pronunciation which we are using. So these are the things. Let's solve one question. After that, we'll be able to understand that how this Coulomb's law work. Little by little, we'll be moving one step at a time so that we'll be able to understand at our level best. So for Coulomb's law, assume that I am telling you that there is one charge of 3 into 10 to the power of minus 7 Coulomb. There is another charge of 2 into 10 to the power of minus 7 Coulomb. There are two charges, and they are separated by a distance of 30 centimeter. Okay, so there are two charges and they are kept in air. One charge is here Q1, one charge is here Q2, and they are separated by a distance of r. R is 30 centimeter, this is given. And you need to calculate the force exerted by Q1 or Q2 when they are separated by 30 centimeters. So this is the question which you are having. So if you have to find out that what is the force between these charges, then it will be k Q1 Q2 by r square, right? This is the formula which we will be using. This is the Coulomb's law. Are you all agree with me that this is the formula which we have to use, right? So show some enthusiasm. This is the formula which I have to substitute. The value of k is, sir, 9 into 10 to the power of 9. You have already told us, sir, this is the formula, right? So this is the value 9 into 10 to the power of 9, and Q1 value is 3 into 10 to the power of minus 7, 2 into 10 to the power of minus 7. Here we have to make some changes because r is in centimeter and we can't take centimeter values. We can't take centimeter values when we are solving the question. So here we have to change the value in SI units. And what are the SI units? We have meter with us. So I need to change this value to centimeter, and when I am changing this value to centimeter, then it will come out to be 0.3, right? So I can say that this will be 0.3 into 0.3. Fine. I can easily remove these zeros and put 10 to the power 2 here. This 3 can be cut with this 9, and the answer is here. Number will be multiplied by numbers only. The powers will be handled by powers only. Okay. So 3 into 2, 6 into 10 to the power of 9, 10, 11. 11 minus 14 we have. So the answer will be 10 to the power of minus 3, and the answer is in Newton. So this is the force which these charges will be experiencing when they are separated by a distance of r, which is 0.3 meter, right? This force is 6 into 10 to the power of minus 3. This force is also 6 into 10 to the power of minus 3. Why? Why? Because there is Newton's third law of motion which is applicable here. There is Newton's third law of motion which is applicable here. Okay. I hope that you are getting and we are on the same page. This is the question. This is a very simple question which I just show you. So in these types of question, you just need to replace the values given in the question, right? So basically these types of questions won't come in your NEET exam, but these are required because we have to make the basics. So let's move, but I need to add some points as well about Coulomb's law. Till now what we have studied, I need to add some points. So I am having a Coulomb's law here. In Coulomb's law, I told you that one force is acting. You can write that force as K Q1 Q2 by R square. And you can also write this as 1 upon 4 pi epsilon naught Q1 Q2 by R square. Right? These are the two things. The value of K here is 9 into 10 to the power of 9 Newton meter square per Coulomb square. The value of epsilon naught here, the value of epsilon naught here is 8.854 into 10 to the power of minus 12. What will be the value? What will be the unit which I need to substitute here for the epsilon naught? It will be opposite of the K, right? Or you can easily calculate, keep this epsilon naught here and put this F here. So Q1 multiplied by Qm will give you Coulomb square, and here we will be getting Newton and meter square. So it will be Coulomb square per Newton meter square. I hope that you are getting, right? So this is the answer which we are getting. So Coulomb's law, this is done. This is done. What is the value? And now about this, the charges are kept in air. Q1 and Q2, these were kept in air. What would happen if I'll transfer these charges? What will happen if I'll transfer these charges in water or some medium? What will happen? If medium is having a dielectric constant, what is dielectric constant, sir? We do not know what is dielectric constant. Dielectric constant is nothing but an insulator, and we have the value of insulator, means we have the permittivity of the insulator, that how they would be providing the permission that whether the charges can move freely or not. So according to that we can move. So we have a dielectric constant here, dielectric constant of particular medium. What is dielectric? Dielectric is nothing but an insulator. Dielectric is nothing but an insulator, right? So if these are the things, if these are the things, then these formula will change into some other formulas, right? And what are these formulas? What are these formulas? What will be? So this formula will become f dash. When these charges are kept in some other mediums, then the formula will be changed. The formula will be f dash, and f dash is, we will be substituting, it will be f upon k. The force will be decreasing. You can imagine that I can easily move my hands when these are in air. But the moment I'll took some other, like if I'll attach my hands with the string, one string, and I need to move my hands, then it will be very difficult. Similarly for the charges, when they are kept in air, there is no hindrance, or when they are kept in vacuum, there is no hindrance. But when they are kept in some other mediums, there is some hindrance. There is some hindrance by the medium for the movement, right? So this is the dielectric constant, means the permission which the medium is providing them. So f dash is f upon k, right? F dash is f upon k. This you need to understand, and I can keep, if I'm keeping this formula only, I can keep this as k divided by small k. Small k is the dielectric constant. So I can keep this as k, small k, q1 q2 divided by r square. So this will be my new formula. And for this type, if I need to find out, then it will be f is equals to, similarly I can keep that thing 1 upon epsilon naught dielectric constant q1 q2 by r square, right? This will remain same here, that f is equals to, f dash is equals to f upon k. Also we can sometimes write f k is equals to epsilon r, that will be equals to epsilon m upon my epsilon naught. So this is relative permittivity as well. This is relative permittivity. So these are the things which you need to know about the Coulomb's law. And now I am moving towards another type of concepts about the Coulomb's law. Shall we move? Shall we move? I hope that you are well versed about these concepts, right? Are you all well versed about these concepts? And keep remember one thing in your life, that phones में iPhone, गाड़ियों में Mercedes, और फिजिक्स की क्लास में मनोज सर की क्लास, there is no, I will be saying, क्वालिटी के साथ कोई समझौता नहीं होगा. इस बात पे संदेह नहीं करना. Don't doubt about the quality of the class, quality of the objects which we are providing. In phones we have iPhone, in cars we have Mercedes, in physics we have me. Right? Shall we move? One more thing I need to share with you. The thing is that if you are preparing for the NEET exam and you are very serious about NEET, then I'll tell you that you need to come to this Telegram channel, because through this Telegram channel you won't miss my updates. You won't miss my updates, you won't miss my PDF material, you won't miss my free classes, you won't miss the announcement, and you won't miss the discounts and prices which we are continuously providing. And currently there are some mentored classes is also going on, means classes on Zoom calls. Classes on Zoom call is happening. So you won't miss my classes on Zoom calls which we are providing, right? So for that you just need to do one thing. You have to keep your phone ready with this scanner code, scan this code and just go on this Telegram channel. And there are our courses also going on. For our crash courses, 90 plus classes I am providing you, 90 plus classes. Duration of the class will be until the date of the exam. Syllabus will be covered from JEE and NEET experts, which is none other than me. So there, the method which we are using is the flipped classroom method. What is flipped classroom method? I'll be telling you. Have you heard about this flipped classroom method, or you are just thinking about this flipped classroom method only now? How many of you know about flipped classroom method? This is the method used by the European universities, and this is the best method which we are having. Have you ever thought that why Indian education is lacking and why the Europeans' education is rising? Why there are more startups coming in Europe and other parts of countries, but in our country startups are very less? Why our peoples are not very creative? Because they are using the flipped classroom method. So I'll be in this, we will be teaching you using the flipped classroom method, and also we will be taking your doubts. We will be solving our own assignments, and you need to follow us on Instagram on APJ Academy. This is the flipped classroom method which I am talking about. Basically, what happened in the flipped classroom method? We will be providing you a short video for 10 to 15 minutes about the topic, and I'll be discussing about the main things about the class, right? About the contents, about the applications of that topic in that, to create the interest in you, and at the same time you will be provided with the study materials which you can go through on your own, because that study material is for your self-study. And when you are done with this first video, which is the very initial video or the introduction type of video, and second one is the study material, so we save our time for the introduction in the class, right, about the topic. You already know about the topic. Second thing, I'll already provided you the study material. The third thing is about the webinar. It's already be third thing, the webinar. So it will be a live webinar. This class is recorded, so you'll be getting a recorded class. This webinar is live. The duration of the webinar is 1.5 hours. So in this 1.5 hours, we will be main focusing on the concept building, and third, the application of that concept in your numericals. Because if you are thinking about to crack the toughest exam in India, which is NEET, and you want to become a doctor from student, you have to change your life, isn't it? And the changing life can only happen if you are dedicatedly solving the questions. It can't happen when you are not dedicatedly supported by the mentors like us. This is the third thing. This is fourth thing is the homework. We will be providing you DPPs, daily homework. We will be providing you the fifth and the final is your homework check. So we will be continuously monitoring you. We will be continuously monitoring you for your preparation. Right? And now we are moving towards the type 2. Coulomb's law. Coulomb's law basically the types of numericals which we are having in the Coulomb's law. I am giving you a full chart. The chart is like that. First of all, we are having a one-dimensional question, 1D question. First of all, we are having a one-dimensional questions with us, right? What is one-dimensional question? In these types of question, you will be having the charges situated in a line. You will be having a charge here, Q1, you will be having a charge Q2 here, you will be having a charge Q3 here, you will be having a charge Q4 here. So there will be multiple charges, and you need to find out what is the net resultant force acting on these charges. So for the resultant, I'll be following some rules. I'll be following one rule through which we will be solving each and every numericals. So the rule is very simple. I made an acronym from that. Acronym for that is RIN. Acronym for this thing is RIN. What is RIN here, sir? What is RIN? I am telling you to solve any question for Coulomb's law, for electrical field and for the magnetic fields, which we will be discussing in the future classes. There is only one rule. The rule is about this RIN. The first method is about reach on the spot. Second method is about checking the individual leaders, checking about that what is the orientation of that, what is the orientation of that individual charge. Check individual leaders. The third one is calculate net effect. So these are the 3 steps, and I'll be teaching you, I'll be guiding you to how to apply these 3 steps, and I guarantee you that if you are pro in applying these 3 steps, you won't face any issues. This is my challenge for you. If you find any concepts better than this in solving the Coulomb's law questions, then I'll give you whatever you will say, I'll give you. This is the best method which I found through my research, through my creativity. So, and this is the first thing which you have to learn in your class 12th. So there is 1D questions where we have to find out this thing, and how we will be finding out the resultant of the forces. So for the resultant, we need to know one superposition principle is there. What does this superposition principle say? There is superposition rule. It says that when there are multiple forces acting on one charge, then resultant you need to find out, and resultant can be easily find out using the vector sum of all the forces, which you are having. So F1 plus F2 plus F3, so on. Okay, so I am telling you that how to calculate the resultant. This is F1, this is F2. We need to calculate F net, and this F net is nothing but a F1 square plus F2 square, and there is some angle between this F1 and F2. I'll be saying that this angle is theta, then it will be 2 F1 F2 cos theta. So this is the resultant force which we are having, and this is alpha here. So tan alpha is F2 sin theta upon में F1 plus F2 cos theta. So this will give me the orientation of or the direction, right? So there is first type of question which is one-dimensional questions, in which you will be having the charges in line, in sequence, it will be there. And in second type of question, what I am saying, that this is the two-dimensional question. In two-dimensional questions, you will be having the two-dimensional figures with you. The figure can be a triangle. In which you need to find out the force on the vertices, or you need to find out the force at the center. There are two things which you need to find out. First, the force at the vertex, and second, the force at the center. So this is what you need to find out. Other thing is that there is square, you will be getting square, and for this square, ABCD, right? For this ABCD, same thing will be there. You need to find out the force at the vertices. Also, you need to find out the force at the center. Similarly, we can add on, means you know that the polygons are unlimited. We have a number of sides, right? There are so many types of questions which can be framed using the same concept. So we can have a triangle with us, we can have a square with us, we can have pentagon, we can have hexagon, and other than hexagon, we will be having a circle, right? So these types of questions will be there, and we will be solving that how to solve these types of questions, right? So first of all, moving forward, I want that I'll be discussing one thing with you, and there is one very basic questions which you might find in your previous year questions as well. So the type of question is, assume that I am having two masses M, right? So these masses, if anything, I will be saying, if anything has mass, there will be a force of gravity acting on that, and the direction is fixed. It will always be downward. There is no doubt about that. That where the direction, what is the direction of the gravitational force which is acting on the body? If the mass of the body is m, right? So direction of gravitational force is fixed, which will be downward. And if I am telling you that other than mass, this object is also having a charge q, then I know that there will be an electrostatic force which is acting on this body, right? There will be an electrostatic force which will be acting on the body. Then you know that there are two forces which is acting currently. First force is Fe, second force is Mg. So there are two forces which is acting on one body, and you can imagine that the length is L, right? So if I'll mark this as angle alpha and mark this as angle beta, okay, I'll mark this angle beta. Given that M is equals to M, means both the masses are identical. I'm writing this as both masses are equal. Both charges are equal. So both masses are equal, both charges are equal, right? So if both masses and charges are equal, then my question is, then what is the relation between alpha and beta? What is the relation between alpha and beta? What is the relation between alpha and beta? Very simple question, very popular question. I'll be taking three types here. So this is type 1. This is type 1 for you. So you need to find out that what is the relation between alpha and beta. Will both these angles are same, or will these angles will be different? So you need to tell me these things. Can you? Tell me, can you? Will alpha and beta are same? Will alpha and beta are same? Very simple question for you. Very simple question for you. Next time, and so these are the three types of questions which I'll be discussing with you. These are the three types of questions which I'll be discussing with you. So I'll be starting with very basic things. This is the first question, and this is very popular question. I am telling you that I am having two balls. There are two pith balls, like just like I am having a cricket ball with me, and I'll assume that this is an insulator, and I am keeping one another ball here. Both of these are having mass m, and I'm also providing the same charges to both these objects. The masses are same, the charges are same. Then what is the relation between alpha and beta? Definitely the alpha would be same as beta. Why? Because these forces are equal, then these are separated by an equal angle, and if these lengths are identical, everything is identical, then this will happen, right? Type 2. In type 2, what we'll be having? Both masses are equal, Q1 is greater than Q2. Q1 is greater than Q2. Then also we know that Fe will be equals to Fe. Why? Because Fe is equals to K Q1 Q2 by R square. It is a product of two charges, right? So if one charge becomes greater than the other charge, it won't matter. The product of the two charges will remain same, isn't it? Because the force depends upon the multiplication of two charges. Always remember one thing whenever you are solving any types of question related to the physics. You have to work in one way, right? You have to think in terms of formulas. This is the only way. So when we are thinking about in terms of formula, then we must know that this is the only relation which we are having. So the force depends upon the product of charges. When the force depends upon the product of charges, then we know that Fe is equals to Fe, and the masses are same. So here also we will be having a relation where alpha is equals to beta. There is no relations other than that. There is alpha equals to beta, right? Next we are moving towards the type 3. In type 3, what is required? In type 3, what is required? What is required in type 3? In type 3, the thing that is required is, here the charges are unequal. So for unequal charges we know that both of these forces are equal, so it doesn't affected by these things. But for masses, if I am having two masses that are different, means this m1 is greater than m2. I am telling you, if m1 is greater than m2, then you can thought about the process. You can thought about this thing. Just feel. Try to feel, because if you do not feel, then you will be thinking that what sir, what is the thing which you are teaching? Whenever you have some option of choosing between the forces, like one object is greater and the other one is not, then I'll be telling you that think in terms of extreme conditions only. Think in terms of extreme conditions only. So I can tell you that if I am considering this m1 object and this mg is applying, I can consider that this mg is huge, this m1g is huge, right? So this force is very huge, and I'm having the other objects here. This is M2. This is M2G. This is the angle theta here. Or I can say that alpha and beta are coming here. So you can easily find out that if this object is very large, means this won't move. Imagine that I am a charged body, right? I do not move at all, and I am having one charge as well. The other body will move, right? Because it is having less mass. Imagine like you are having an earth which is having a mass m, and you are here. You are having a mass m, and when you jump, the force on you and the force on earth are same, right? As per Newton's third law of motion, the force which is applying on you and the force which is applying on earth are same, isn't it? These are same. But the condition here is that your mass is very less, and if your mass is very less, then the acceleration is force upon mass. Acceleration is force upon mass. And when your mass is very less, then acceleration will be high. So you are going to accelerate, not earth. Similarly, when we are here, m1g is very large. This force are already equal. The acceleration will happen in this only. So here I can tell that beta is greater than alpha. So this angle will be large. This angle will be very less. I hope that this is clear to you. Please make a note of this question. This question is very important. Please make a note of this question. This question is very important. And if you are done with this, we can move to the other part, which is having a feel of force. Imagine that we are having two positive charges. Imagine that we are having two positive charges separated by some distance. Right? Imagine that we are having two opposite charges. Let us mark this as Q1 and Q2. Both these are positive in nature. And imagine that you are placing one positive charge here as well. The charge on this is Q. The charge on this is Q. When you are placing this charge here, then what will happen? From this charge, from this Q1 charge, this force, when this is positive charge, this is positive charge, force will exert on this side, right? When this is positive charge, this is positive charge. According to the law of Cavendish, Cavendish was a scientist who gave us the law that same charges will repel each other. So according to this law, we know that positive and positive repel with each other, right? So when positive and positive repel each other, what will happen? The direction of the force will be in this direction, right? This will be in the direction, right direction of the charge. Or if I am standing here, then it will be in the direction of left, isn't it? But similarly, if I am telling you that what will be the force from this charge, you will be going here and you are saying that, sir, this is positive, then the force will be in this direction, isn't it? Let us feel this thing. Give it a moment. Feel this thing, isn't it? If I am telling you that the distance from here to here is x, earlier it was r, the distance from here to here is r minus x, then you will be saying that the force here will be k q1q divided by x square. The force here will be k q2q divided by r minus x ka whole square. And if we assume that these charges are balanced with each other and there is one point where both these forces will be balancing each other, then I will be saying that at that point there will be zero force, isn't it? When both these forces are equal, then the resultant force is 0. If imagine that I am having a charge, here, I am pushing this ball here, then when this ball is not moving, why this ball is not moving? Because force is cancelled by the other force. One force is cancelled by the other force. So at equilibrium, if we are saying at equilibrium, summation of F will be 0. So at that point, I can easily say that F1 is equals to F2, right? So I can write K Q1Q divided by X square is equals to K Q2Q divided by R minus of X square. We can cut this Q and Q, this and this, and we can easily get one relation Q1 Q2 divided by X square divided by R minus X whole square. This is the relation which we are getting, and we will be using this relation while solving. Numericals. So what is the relation here? The relation is X R minus X is equals to under root Q1 by Q2. So this is one important relation which we will be using. This will be applicable on electrical field as well as on the forces. Imagine that I am having a charge 16 microcoulomb here, let us say Q1, this is positive, and here I am having a charge 4 microcoulomb. Okay, so I am having two charges and they are separated by a distance of 3 meters. Then if you need to find out that where is the point where I'll place one charge of 1 microcoulomb, where the net force is 0, you need to find out that point. So how you can find out? That point? This is easy peasy, isn't it? This is easy peasy. This question will be what? This question is easy peasy, and you can easily find out. How you can easily find out that question? Sir, you already told us, sir, we do not need any hint for that. You already told us that we need to divide these things. So it will be 16 divided by 4. That means we will be getting around 4, and the root of that 4 will be 2. So 2 is equals to x upon 3 minus of x. This is this thing you can directly write down, isn't? Can't you? It will be 6 minus of 2x is equals to x. So you will be getting 3x is equals to 6, x is equals to 2. So 2 meter is the distance. 2 meter is the distance. So this is how you can easily find out the location of the point where the net force is 0. This is the point where you can easily find out what is the location of the 0. Done? Shall we move? Okay. The same concept if I'll be using, here is plus, here is minus charge, the charge is Q1, the charge is Q2, they are separated by a distance of R, okay, and I need to find out that where can I place here a charge plus Q. Will it experience any zero force? Let us check. First go to that side. You will feel that there is positive charge. Here is also positive charge. So it will repel. Positive, positive repel. So force 1 will be there due to Q1. From Q1, the force that is exerting will be F1. The charge here is Q2. Q2, this is positive charge, this is a negative charge. Both these forces are in the same direction, they won't cancel out each other. So here, in between, when there are opposite charges, positive and negative, the net force, F net, can't be equals to 0. When there are opposite charges, F net can't be equals to 0. So we get to know that this is the reason, okay, the area type. This is the reason where the charges can't be equals to 0. Then what will happen? If we will go towards the other side, then at here, if I am keeping this plus Q charge, this plus Q1 will be exerting a force. Let us say this is F1 from force, the force from this Q1 will be F1 and the force from this Q2 will be F2. These are in opposite direction. So there might be chances that this force can be equals to 0. So yes, there are chances. But what is the distance from here to here? This is R plus X. This is R plus X. So I can easily write out Q1 by Q2 R plus X divided by X. So this is the relation which you can use here. Okay, please make a note of that so that you can easily mark. So you can easily mark the questions which might come on your side for NEET exam, right? And if we will be moving towards the electrical field, then electrical field is nothing but it's a concept of aerial, right? It's a concept of area where the influence can be felt from the charge. So electrical field formula is F upon Q. So electrical field will come out to be F KQ divided by R square. The Q is source charge. Right? The direction of the electrical field will be in the same direction as that of the force felt by the test charge. Now coming to the JEE and NEET courses which we are providing. So there are two types of courses which we are currently providing, right? So we are currently providing the mentorship program, one-to-one mentorship for all of you who are enrolled in our courses. This is not provided by any coaching institute. If you can track this, one-to-one mentorship is not there, personal attention is not there. If you want personal attention, right, if you are a parent or you are a student, then I will be saying that in the exam like NEET, you will need some hand-holding, initial hand-holding, right? So initial hand-holding will be provided by me. So there are special prices for smart plans which is currently going on. The plan is for only 2990. The plan is only for 2990, and for this 2990, by paying this 2990 amount, you will be getting so many things like structured course you are getting, complete material you are getting, complete notes, study material is already there. Okay, so test series is there, So there are so many things which you are getting. So do not wait. If you really want to crack this toughest exam and you really wanted to enjoy this journey from becoming a doctor from a student, you have to join this, right? You do not miss this opportunity, because this is a once in a lifetime opportunity when you are preparing for the NEET exam. Do this right now for the last time. Enroll in this course and you won't feel that you wasted anything. You will feel very enriched that yes, this is the right thing which you had done. This is the kind of an investment which you can do on yourself. So scan this code and enroll now. And when you are enrolling there, if any code you can use, you can use that code Manoj JE or Manoj NEET. This is the code which you can use. So on APJ Academy, we are currently nurturing the young minds to become doctors and engineers. This is our mission, to make education affordable to everyone. And for that, we are providing this special price. If you are enrolling this, you can use this code. These are the facilities which we are providing. And even if you want more tests, we will be providing to you at no extra cost. Okay. Till then, subscribe this YouTube channel. If you do not want to miss this opportunity to learn from us, right? You can join our YouTube channel, and this is free of cost. For regular update, you need to subscribe this YouTube channel, and we are ending this class here only. So bye bye.